Okay, welcome to this next video. Now, we're going to be talking today about angles at a point, and we're getting to more the geometry side of our measurement unit. Our learning goal now has changed a bit, so now you're going to be solving simple numerical problems involving angles formed by a transversal crossing two parallel lines, and also name the angles formed by the transversal. Okay, big sentence, some scary words in there, but I promise you it's very easy if you do lots of practice. Okay, all right. So at the end of this lesson, you'll want to be able to name the different angles formed about a point and apply geometric reasoning to angles formed about a point. All right, let's rewind the clock 2,300 years and let's talk about this guy here called Euclid. Okay, he's a pretty cool dude, and he wrote this book called The Elements. Okay, now all of the geometry that you'll be worrying about this year, all of it was sort of written and or at least compiled together and given a set of rules by this guy here called Euclid. And he had these things that are called, so he had axioms of geometry. Okay, and that's this idea that they were the sort of fundamental ideas that are true so that all the other things can be true as well. And so he defined things like points and lines and circles and angles and parallel stuff. He defined all of those things so that you can just use them and it's okay. So he's a very intelligent guy and really started off some huge foundations in a lot of the mathematics that have been used throughout the Western world. Okay? All right, let's move on and have a look at some of these ideas then. Okay, so we're going to be talking about angles today. Now, angles are classified by their size, okay? So acute angles like this, they go from 0 degrees through to 90, okay? So 0 and 90 is up here, so that would be an acute angle. Now, we write angles, by the way, with if this was point A, B, and C, okay? We would write that is angle A, B, C. So wherever this piece here, this bit of the angle there, that point is called the vertex, okay? And that one's in the middle, okay? And this one here is called, this line here is called an arm, okay? So vertex and arms, just the different things, ways for you to talk about angles, okay? Now, a right angle is exactly 90 degrees. Let me show that with a little box thing. An obtuse angle goes from not 0 to 90 degrees. 90 degrees to 180 degrees, okay, is an obtuse angle, all right? A straight angle is exactly 180 degrees, okay? A reflex angle is 180 degrees through to 360, so this outside angle here, not the inside part, the outside piece here, okay? And a revolution is exactly 360 degrees. So it's 360 degrees around a single point, okay? 360 degrees inside a circle as well. All right. So when two or more lines meet, different types of angles are formed at the intersection. So these are all really important. So knowing the names of the angles, that's fine, but how to use them is the important part, okay? Right, so now adjacent angles share a vertex and an arm. So if we had A, B, C, and D, so we would say that angle ABC is adjacent to angle CBD, okay? Because they both share this vertex B and they share this arm, this one here, okay? So we've got two angles, this one and this one here, okay? All right, so they're called adjacent because they're right next to each other. All right, now, a pair of complementary angles add up to 90 degrees, okay? So we've got one angle here, alpha and beta, okay? So, and they both add up to 90 degrees, as you can see with the little right angle inside here, okay? Now, it's very important that you only go by the information you are given. If that right angle little square thing wasn't in there, that would not be a right angle, okay? You have to be told that it is. Doesn't matter if it even super duper looks like it, okay? Super, absolutely important. Okay, so now we're going to look at how we can reason and use logic to come up with stuff. Okay, so we can say now that angle alpha plus angle beta, okay, so that's this one here, alpha, and beta is that angle there. Both of them added together equals 90 degrees. Now, we've got little signs for these to use, so we write next to that, the rule that we're using is the right angle rule. Okay, now to remember that right angles, angles that sum up to 90 are complementary, a little mnemonic for you is that it is right to give complements. Okay, so there's the right angle part and complementary. A little bit silly, but if it helps you remember, that's the one for you. Okay, so a pair of supplementary angles now, they add up to 180 degrees. So here we've got the angle theta and the angle phi, sorry, and so they add up to 180. So we write theta plus phi equals 180 degrees, and a little sign for that is a little straight angle like that. Okay, so that tells us that we know this is true because they lie on a straight line. Okay, it's very important that you're able to sort of put those together. Now, I don't have a silly rhyme for supplementary, it's just that if you can remember the complementary one, supplementary is obviously the straight line. Okay, all right. And angles in a revolution add to 360 degrees. Okay, so we've got angle A and angle B here. Okay, so we could say here now that angle A plus angle B is equal to 360 degrees because of our revolution rule. Okay, so sometimes it's called a lollipop rule, but you can see it's like the line with the angle going all the way around. Okay, right. Another one here is what vertically opposite angles are equivalent to each other. Okay, so if you've got two lines intersecting like this, it means that this angle here is the same as this angle here, and this one here is the same as this one here. Okay, so let's give them some names, A and B, C and D. Okay, so we write A is equal to B because of our vertically opposite angles rule, and C is equal to D because of our vertically opposite angles rule. Okay, so that's how we use that one. And this one's just more of a word, so perpendicular, should have had that bolder, but perpendicular lines intersect each other at right angles. So if there's a right angle between these two lines, we say that line AB is perpendicular to line CD. Okay, so AB is perpendicular to CD. Okay, that's what that means. All right, let's have a look at some worked examples. We're going to evaluate the unknown angle in the following figures. Okay, so here we say, so we've got x and 30 together inside a right angle. So we say x plus 30 is equal to 90 degrees. So x plus 30 degrees is equal to 90 degrees because of right angle rule. Therefore, so you can do a bit of algebra. So you subtract 30 from both sides and we're going to get x is equal to 60 degrees. Okay, simple. Okay, right, let's move on to the next one. So now we've got a straight line across the bottom and an x and a 120 degrees together. So we say x plus 120 degrees is equal to 180 degrees because they're on a straight line. Okay, so we subtract 120 from both sides and we get x is equal to 60 degrees again. Yay! Okay. All right, next one. So we're still on a straight line now, but now we've got three angles, x, 52, and what's this? It's this right angled sign, so, which is 90 degrees. So we got x plus 90 degrees plus 52 degrees is equal to 180 degrees because of our straight line rule. And so we subtract 90 and 52, 142 from both sides, and we end up with x is equal to 38 degrees. Okay? All right. Let's look at this next one here. So now we've got we can now look all around the point. So we've got 215 degrees, which is the angle going around this way, and then E, which is the angle on the inside. So we have E plus 215 degrees is equal to 360 degrees because of our revolution rule, okay? And subtract 215 from both sides, and we get E being equal to 145 degrees, okay? All right, I know this video is running a bit long, but I'm trying to show you a lot of examples so you can see all the different rules in play. Okay, so here's one here. So x and 51 degrees, it doesn't matter what these two here on the side are, because we can say that x is equal to 51 degrees because of our vertically opposite angles rule. Okay? Now, this one here is a little bit trickier. So, we've got to what you want to try and do when you're going about these is say to yourself, what information can I find out? So, the first thing we're going to do is say that, well, these two angles here are on a straight line. So, I can use that to figure out this one here, which is gamma. So, gamma plus 115 is equal to 180 degrees because of our straight line rule. Therefore, gamma is equal to 65 degrees. Okay, and that's fine for the other side too. So both of those are equal to 65. Now, a lot of information in this video, and that's okay. And the number one thing to do is just practice, practice, practice with these. You have plenty of opportunities, and we'll even do some great challenge stuff at school. One particular problem where I'm willing to throw maybe even between like 20 or 50 bucks up for the prize because I'm very interested to see if anyone manages to be able to get it right. Okay? Have an awesome day, and I'll see you at school.